buoyancy and more fat, if you will, in bridges that were designed, in the 50s and 60s, and those bridges were lasting longer. And then we had these bridges signed in the 80s that were having trouble. So where was this new technology? Why wasn't it being leveraged for bridge design? So if you think about how bridge design is done today, it ends at the commission of the bridge. The bridge designer cuts the ribbon and he or she is done. That's the end of their contract. There's usually no extension. In some specialty bridges, there are inspection procedures or recommendations. However, it's up to the bridge owner if they want to use them or if they want to just go with Pontus or whatever other program they're familiar with. There is a limited consideration for any long-term behavior. And structural modeling is not part of the submission. Even if it's done in the office, it's never turned over to the owner. And there's kind of this idea that the owner couldn't use the model, but if you poll at the DOTs, at least in New England, they all own at least one, they own, I would say, one copy of GT Strudel or SAP 2000, and they have a lot of engineers that can use those programs, but it's not part of the submission. How they do bridge inspection is basically how you manage your bridge, and everybody knows it's every 2 years. It's visual inspection, and you get a condition rating. Most of the time, that's called the load rating. The bridge is load rated on a per element basis. No matter how good your inspectors are, no matter how much training they have, there are 3 problems with bridge inspection. It is always subjective, no matter how much training they have. It is based on their experience. You can't see everything, and it's elemental. That's just by the nature of the program. And how it is so this is actually photos that were in the bridge inspection report for that Vernon Ave bridge that we showed here prior to its replacement. Local stories told us that over 80% of the deck was covered in 2-inch thick steel plates because there was holes in the deck. But yet, here's the rating. It was a 3, 4, and a 6. So even with holes in your deck, you still got a 4. Okay? So our central thesis is, how can we now do that long-term design? And we want to leverage our advancing technologies. And those technologies are different than they were in 1990. It's instrumentation, it's advanced analysis, data management techniques, remote sensing, and improve the idea of bridge design, not just management, but from the beginning of the bridge. So our new design paradigm that we are envisioning is that it goes beyond opening day. And part of how it could go beyond opening day is the creation of a baseline model. Whether it is the enhanced designers model or enhanced researchers model that was shown, but some model that has parameters and protocols in place from the state that is part of the submission. So there is a 3D representation for inspection information, for performance information that carries on with the bridge. And then it would modify our approach to bridge management, which is right now reactive for the most part, and make it proactive. If you have a 3D representation, when you get an inspection report, which isn't just 1,500 pages of how each element looks, but it's actually a 3D image and you can see the section loss, because it's visual, you'll be able to make better decisions and be more proactive. So the idea of the baseline model is really what this project was looking at. There's a lot of assumptions in design and a lot of assumptions in model creation, and that model should live and evolve with your bridge. How do you integrate data management tools? So we'll be using Vernon Ave Bridge as well as the Tobin Bridge, which has also been instrumented by this team to develop that type of technology and that type of look. And then this is really what we have just been talking about, really leveraging those technologies, because as we've kind of heard today, it can sound a little hollow to a bridge owner when you tell them it's a smart bridge. But if you show that it can be used for load rating, it can help you verify distribution factors. If you have temperature sensors, it may help you with salting because you can see the temperature of your deck. It has to be not 50-year benefits, but also today benefits. And so really leveraging that technology. And that really is our focus here. And making bridge design and management an integral part and using baseline modeling and instrumentation. So thank everybody for listening. This is our team, and as I said before, it really took a village, and if you really want, if we kind of are coming from the perspective, if you want instrumentation and modeling to be part of the everyday process, everyone has to be involved from the steel fabricator right on up. So thank you. I think they're all functioning right now, right?
Jesse?
There's a few in the deck that were working but are no longer working.
But majority are working.
Majority of them are functioning.
And the ones that worked from the beginning are still working.
Yes. We haven't had any values in temperatures. not in the concrete deck. That's part of the putting some existing concrete you have to worry about.
Any other question? Yeah, please.
So it seems to me that the challenges that you outlined here are less on the engineering side and the monitoring side and the modeling side, but more on the municipal policy, maybe state policy level, maybe even national policy level. What are the chances of this wonderful concept ever being rolled out nationwide, on a broader scale?
This is a lot of discussion, and we're not trying to minimize the challenges on the modeling and monitoring and data acquisition side, but there are these municipality challenges, and it starts with believing that this is worth anything. There's been a lot of discussion at the federal highway level that there's no carrot for bridge owners to do this. You don't get to not inspect it every 2 years if it's instrumented or modeled. You still have to do that. Are your inspections more meaningful? You have to have that goal. We're not the only people looking into this. The long-term bridge performance program funded by Federal Highway is also kind of looking at how do you roll this out. So I'm hoping, maybe not in Masoud's lifetime, but in my lifetime,
I'll be
that this would become part of the vernacular. But getting, what we're finding from FST also is that when they offer this as a bid package, and I think if Brian were here, that's what he would say, they are kind of looked at a little differently, like, oh, they can offer something else. Because if it's rolled into the initial cost, it doesn't look like a big ticket item. And I think that's the mindset that we're looking for, that when the bridge designers are bidding for these projects, if this idea of instrumentation is rolled in, it doesn't look like a big ticket item, but you have this benefit. And I will tell you that the structural steel fabricators of New England are very interested in this, because steel is trying to make sure they don't get edged out of the bridge market. So they're looking at how can we develop technologies that we can provide instrumented girders, and that's part of our process. Again, being the daughter of a fabricator, but again, being part of the process, and again, it's not a big ticket item. And it's that big ticket that scares people away.
I think there is a trend of talk to the owner or even to FHWA about a life cycle.
Yeah.
Value that you are in the long term you are going to save a lot or much more tenfold of money in the wrong way for maintenance. That's the first thing. Second thing is, are you be able to convince the owner or the designer already specify that you need to put some instrumentation? In this case, it does. It did. So there are these two sides of things. You have to convince people there is a long-term saving, and then next one is the owner willing to really pay that initial cost for it. And if you can imagine that too, I think you have a very good chance. So the state highway, our federal highway department already aware, after 20 years of health management that I have been doing for that 20 years, right now they're starting to have that bridge testing program. And that is a huge program right now in the University of New Jersey.
Rutgers.
University. Yes, Rutgers University. So that is a part of the precursor to see whether we can develop a program for this long-term bridge health management.
Another part of this technology transfer is to educate new bridge engineers who are well familiar with the structural health monitoring, instrumentation and testing. And for example, 2 of our students now work at FST. So now when one is doing static and one is doing dynamic testing. So when they are bidding on new bridges, then they also can include an instrumentation package in there. And also these new engineers someday will get to the management level or move to highway, the DOT departments and act as owners. So educating new engineers, bridge engineers is very important.